Okay, so we are going to start off our first geometry lesson by looking at 15.3 with tangents and circumscribed angles. So let's go ahead and start by looking at the tangent radius theorem. It says that a tangent is a line in the same place as a circle that intersects a circle in exactly one point. As we already reviewed, this is going to be a tangent line, and then the place where this line intersects the circle, this is called a point of tangency. It says here this is circle C, and we call it C because there's a C in the center of it. And we already know about tangents and how it's just going to touch the circle at one point. So I'm going to scroll down here and skip past the Explorer to the tangent radius theorem. In this video, we don't have time to explain where it came from or prove it, but I'm just going to say that if we have a tangent and we have the radius, a radius is going to be the distance from the center of our circle to the edge, these are going to meet at a 90-degree angle. So you want to go ahead and write that down in your notes, that if a line is tangent to a circle, then it's perpendicular to a radius at the point of tangency, which means that this is going to be 90 degrees. Reflecting on that, we're going to go ahead and say that we've got two tangent lines, and they're on opposite ends of the circle, where we have two radii, which come together to make a diameter. It says here, what can we conclude about the tangent lines? Well, since we know that we have an arc here, and that arc is going to be half of the circle, the semicircle, and that connects to a tangent line and a secant line, the secant line being this AB, we know that this angle right here is going to be 90 degrees. So we could say that this is 90 degrees and this is 90 degrees, which is one of the reasons why we can prove that it's going to be 90 degrees. But we could also say that these two tangent lines are then going to be opposite each other. They're going to be supplementary. They are going to be parallel. That's what we're going for. They're going to be parallel. At any point during this video, please go ahead and pause and reflect before I discuss my solutions. I'm just trying to make this kind of quick so the video isn't too long. The next thing we have here is the circumscribed angle theorem. It says that a circumscribed angle is an angle formed between two rays of a common endpoint. So there's this tangent and this tangent, which means that the circle has an angle on the outside, and we could say that that angle circumscribes. Or it's a circumscribed angle. How do we figure out this angle and what's its relationship to the arc? It says here that the circumscribed angle and its associated central angle, these are going to be supplementary to each other. So how do we figure that out? Well, we've got this angle here and this angle. These are going to be supplementary. Well, if we know from the previous one about our tangent lines that this is 90 degrees and this is 90 degrees, and we know that a quadrilateral is 360 degrees, we could do 360 minus 90, and you will end up getting 180. The remaining two angles are going to be 180 degrees, which shows that they are supplementary. The last thing I want to show here before we do an example is we've got two tangent lines, and we want to show that these lines here, the KM and KN, are going to be congruent. So what we can do is we could draw a line between KC, and we have a right angle, and we have a right angle, and they share this leg, or they share the hypotenuse. Since this radius is going to be the same as radius, as each of the radius, then we could say that these two triangles are going to be congruent because they are, we have a hypotenuse leg situation. So the two triangles are congruent, therefore these sides are congruent as well. And that's going to be important for your homework. So when you have two tangent lines that are going to connect to create a circumscribed angle, we could say that those two legs are going to be congruent to each other. So let's go ahead and go on to page 812. And page 812 has an example that's not going to be part of your homework, but it's going to have some relevant stuff that we want to go over. It says here that KJ is tangent to the circle so tangent to the circle, and KL is also tangent to the circle, and that ML is 138 degrees. We want to find the measure of angle M. Knowing what we just did with the previous thing about our relationship between this angle and our central angle, those are going to be supplementary. So we can say that this is 140 degrees. Since we know that's 140 degrees, we can also say that JL is going to be 140 degrees. And then we can just figure out the rest of the circle here. Oh, let me move that back. We know the circle is 360 degrees. We can get rid of the 138. We can get rid of the 140. 140. And then we will end up having JM, which I think is one of the angles we need to find. But I'm just filling out everything on the diagram that I can before we continue on. So let me get 360 minus 138 minus 140. That leaves us with 82. So we could say that this is going to be 82 degrees. And then let's go back to our problem. So our problem wants us to find measure of angle M. Okay, so we want to find out this angle here, and notice that this angle is an inscribed angle relating to this arc, and the inscribed angle is going to be, measure M is going to be 1/2 of JL, which we know as 140. So 1/2 of 140 is going to be 70 degrees. So that's going to be the measure of angle M, 70 degrees. And then the last thing I think was to find the measure of arc MJ, which we just did, 82 degrees. So I hope that is enough for you to be able to do the assignment down here. And please let me know if you have any questions.